Hi, welcome to my video on the motion of a particle in a straight line, and we're going to find in this video the starting value, the position that it starts at. We're going to find the velocity, and we're going to find the acceleration. So here we go. I have a little chart made up. The equation of a position particle, these are the equations here, different equations, and this is a linear, quadratic, a cubic, and a cubic. So let's find the s of t, which is position at time of 0 when t is 0. And let's find the velocity, which is s prime t. And let's find the acceleration, which is s double prime. And notice that again, the derivative s double prime is also the derivative of the velocity. So here we go. So if we put 0 in here, if we put s of 0, we get negative 4 times 0 plus 2. Oh, don't need that. So that's 0 plus 2, which is 2. So in this equation represents the position of the particle. It starts off at 2. And we do the t prime, the derivative of 4t, negative 4t is negative 4, derivative of 2 is 0, so the velocity is 4t. Because it's a linear, the velocity related to the slope is always negative 4, so it's going down. And the s double prime t is the derivative of this is the velocity, which is, so that you could say this if you want. So the derivative of the velocity is, that's a constant, so that's a 0. So the acceleration, and I'll keep writing this down for a while, but you'll see that we have do the derivative, we get a negative 4. So it's a negative 4, and again, if it's in terms of m meters, the velocity is meters per second, and the acceleration is meters per second squared. And position is 2. Okay, let's try another one. We have define st when t is 0, so the st is 0, so that's a 0 squared plus 5 times 0. So that's a 0 plus a 0. So this particle starts off at 0. And s prime, we get the derivative here. Derivative of 2t squared is 2t. Derivative of 5t is plus 5. And the double derivative, which is, again, that's the acceleration. And this is also the velocity. So when you get the derivative of this one, you get a 2. Derivative of 2t is 2. Derivative of 5 is 0. So there's your velocity at time t, and this is your acceleration at time t, but your acceleration is always a 2. Now let's get when s of 0 for this one. Put a 0 in here, and we get negative 3 times 0 squared minus 4. 0 squared is 0, negative 3 times 0 is 0, so the starting position for this particle is negative 4. Notice it's always a constant. I can look at it quickly and say, this starts at 2, this starts at negative 4, this starts at 0, because the constant is 0. This one starts at 3, and this one starts at 0. But I can do that quickly, but I'm just putting 0 in to show you. So s prime t, so we get the derivative. Negative 3 times 2 is negative 6, and we decrease the exponent by 1, so 2 minus 1 is 1. Derivative of 4 is 0, and so that's double prime t. Derivative of negative 6t is negative 6. Again, the velocity is negative 6t, and the acceleration is negative 6, so it's going downward, which makes sense. There's a parabola opening downward. And notice this is plus 2, this parabola is opening upward. So think about that. And again, that's the velocity, which is saying the same thing. And this is the double derivative. Acceleration is derivative of the velocity, which is, so there it is, and that's a -6 again. Double derivative is the acceleration, derivative of the velocity is the acceleration. So just keep mentioning that. And the at time 0, so this one is 0 cubed, 2 times 0 squared plus 3. 0 plus 0 plus 3. So the starting position is 3. And the prime is the derivative of t cubed is 3t squared. Derivative of 2t squared, 2 times 2 is 4, so it's a 4t. Derivative of 3 is a constant, is 0. And your double prime t is your acceleration. And the derivative of, this is your velocity. And the derivative of your position is here. The derivative of this is 3 times 2 is 6, so that's a 6t. And the derivative of 4t is 4. Again, that's your acceleration. And we have one more to do just to drive it home. I'm always a believer of more examples we do, the better. At time t, we got 1/3 of 0 cubed, 1/2 of 0 squared, plus a 0. So that's a 0, and that's a 0, and that's a 0. So this one starts off at 0. And the first derivative, which is the velocity, so 1/3 times 3 is 1, so it's t squared. 1/2 times 2 is 1, so it's a -t. And derivative of t is 1. And your double derivative of your position curve, derivative of t squared is 2t. Derivative of -t is -1. And the derivative of the constant 1 is 0. So there's your first derivative, which is your velocity. And this is your second derivative, which is your acceleration. But it's also the derivative of your velocity. So when I take, this is your velocity, when I do the derivative, I get my acceleration. So that's just explaining the doing the first derivative of a position curve is velocity, second derivative is acceleration. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.